Hi everyone, it's Nono here, and this is one more live stream. This is live stream 120, and we're going to see today how we can use Hugging Face's pipelines API from their diffusers library to run some of the state-of-the-art machine learning model for image diffusion. This is image synthesis with machine learning models in a really easy way. We're not really going to have to get into a lot of detail. We'll be using high-level features of these things. We'll see how to run these things on our machine, how to run it in Google Colab maybe. But I'm going to be preparing today specifically Python scripts and open sourcing them so we can use these models really easily. I will remind everyone that if you're not subscribed yet, to subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. Give me a thumbs up if you're enjoying this type of content. And remember that when I get time, I add timestamps to the video description and the timeline of the video on YouTube so you can scroll to the most interesting parts. I would also invite you to join the Discord community. If you're not there yet, you can ask questions, share projects that you're working on, meet other people. And you can also follow the channel at lu.mas/nono, where I will be scheduling important events and future live streams. For those of you who don't know, I also host the Getting Simple podcast with interviews with interesting people that some of them are coders and machine learners, other people are architects, and there's a bit of everything there. And last week in live 119, we were also looking at how to generate images with diffusers. So I'm going to repeat here what we're going to do today. We're going to take a look at the diffusers library, look at what pipelines are, and do image synthesis. So let's get started. Let's get coding. Say hello in the chat if you're online. Let us know where you're connecting from and what you're working with these days. So let's go for it. Okay. Great. Okay, so the first thing is an intro to the creative image generation repository that I'm putting together. So I'm going to open a new tab on Google Chrome, and I'm gonna go directly to that repository. So this is at github.com/nonoesp, and the repository name is Creative Image Generation. If you go here, you're gonna see that I have started a guide on how to set up your Python environment with Anaconda here, and we're going to be completing this and trying to clean up some examples. I'm here joined today with James McBennett, who I'm working on with to prepare some of these scripts and collaboration. And yeah, so there's nothing here yet except for some utility functions and a script to change the speed on GIFs. So yeah, we're gonna be jumping from place to place today. So yeah, expect a lot of different jumps. But let's actually open the local version of this repository on my machine on Visual Studio Code. You can see here that the main things I've been working on so far, this list of scripts, is working with models like ControlNet, SDXL, which is Stable Diffusion XL, Stable Diffusion, and some other models. I'm running on an Apple Silicon M3 Max Mac, so you can expect that these things are going to run faster on my machine than in others. We've also tried, like most of these things, or I would say almost all of them, work in Colab the best because you have CUDA there and NVIDIA GPUs. The thing is, why I try to do this locally is because the models from Hugging Face get cached on your machine, and because the Python packages can be installed locally and you don't have to reinstall them all the time. So yeah, so maybe the first thing we can start doing is try to organize this a bit. So we're gonna have different models here. So maybe I was thinking before that the best way maybe to have these organized, there are some things that are didactic scripts that have the param prefix to explain how some of these params work and make these models work differently. So maybe, you know, some of the things that I'm talking about, I'm gonna try to write here. Let's see. Uh, mm, mm, mm. There are a series of Python scripts with the param prefix on their name that serve as an example to understand each of the following concepts. And we can link to these ones later, so we could try to see how that looks. So this is like param seed. So here, not sure if I can just do this. So let's actually try. So if I push this to the web and add these changes, test, so add param seed and link to it from the README. For those of you who don't know what I'm doing, I'm actually using something called Git to do version control, the track changes. And what I did now, I actually pushed to that repository a change that we can see here as a commit. You see, this is the message I sent. And we go to commits, we see all the individual changes I've made. And if I click one, it's going to tell me what things were added or removed in that step. Okay, so let's see here. We linked from this seed here. And if I click, it links to the proper location. So we can just do that type of linking. Okay. All right. So I guess we have param guidance scale as well. Okay. And now we're linking to this one as well. All right. So that gets us a kickstart here. It seems like my connection wasn't working great at the beginning. I'm not sure. We lost some packages there. I don't know if you noticed. Okay, so let's keep going. So we have these scripts here. And as I said, so we have some that are params. So for example, we were looking at many different things here. This exercise, same seed, different prompt. We were trying to take a look at different things. Okay, in here, what I try to do is have a prompt that gets a piece of it changed. So we have the same prompt. I'm going to remove this part here. And for, oh, seems okay. It seems my connection is really bad. 1 second. Let me try to figure out what's going on. Okay, so I'm testing here to see. I've reset a few things, so let's see if we don't get any connection problems. I'll be tracking here if we drop any more frames. Okay, so the first thing to clean this one up, we have a few things here. What I wanted to show is I was trying to iterate here, so let me explain this script here. Here we would actually have these values for the word season. Create the prompt variations. Okay, I'm gonna set my steps just to 2 just to try this out. In the torch device, blah blah blah. All right, so here I already have my environment that is called diffusers for this case, and I'm gonna just run the param seed example. Okay, so these loads are model, and now it's gonna start generating just for 2 steps. Non-safe for work content. Right, let's try with a few more steps here. So let's remove these ones. All right, so this is actually really bad because the guidance scale is set to 1. We can actually remove this from here and generate again. Okay, great, so it creates these ones for me. Okay, so this is working with Stable Diffusion v1.5. It seems this model is probably better if we generate for a lot more steps. Let's just try, well, let's actually try to improve the prompt. All right, so I think this example is ready to go. This device, I need to check what works for people. So I want to see like this torch device, I want to make this a global config because I want this to be globally applied to all the samples. Right, so we are generating there, and it does seem that even with the same steps, we get something a bit better with 5 steps. So let's actually make 25 steps to make sure that this is working a bit better. And I'm surprised that this machine is handling the generations pretty well while I'm live streaming and recording locally. It's pretty cool. Well, these are such much better examples than what I got before. I'm actually gonna upgrade some of my slides with this. It's pretty neat. Fall, this is fall, winter, spring, summer. Okay, and one thing that I want to do as well is that it's pretty hard to reproduce your examples once once you have generated the images, because the only information that you have is the image. So one thing I want to do is get the save the information that I will need to run a specific generation again, right? There are some platforms that do that for you. One sec. What am I doing here? All right, now we have this. They do. Now we have this slide here with our newly generated images. Great. Seed 0. So this thing that I'm doing here to report, this is what I want to do, like to report the generations that we've done in a way that can be displayed later. So maybe, I'm gonna, let's see what happens if I set this to the CPU. Would it also generate? Much faster, so much slower. So yeah, with this is npm is metal performance shaders for Mac. All right, so we're done with this example. I can directly add this to the repo. So update param, so update seed parameter example, and we push. Great. So some things that we probably want to do that I'm gonna put on the README is let's add a to-do list here. To-do list. We're gonna scripts to explain each parameter. So we need probably here param width, height. We need others here. We're gonna create a method to store generation parameters in like YAML or JSON next to the file. A utility library to for like creating animated GIFs, montages, cleaning prompt names, file names. And for those of you who are connected online with us today, I would say hi and say hello in the chat. Let us know where you're connecting from. And also if you can see me and hear me okay. There was some connection issues before, but it seems like it's now being solved. Okay, so dataset preparation, we need to see like how to create an image caption in dataset, how to train LoRa's, the efficient LoRa's. Yeah, it says here. Okay, let's close stuff here. Great. So as I said, I'm gonna try maybe to sort these scripts by name. We have different model types. So there's two ideas. One is to sort it by model name. So for example, control net, and the other one is to sort it by task. So depth to image, text to image, blah, blah, blah. So I'm tempted to do by task, but at the same time, I think it might be easier the other way. Stable diffusion, text to image. Maybe that's the way to go. Yeah, I'm not really sure what the best way is, but yeah, any thoughts on what's better on the chat or comments? Hmm. Okay. So what things are we doing? We're right now we have a way to make a GIF from a set of frames with Python and without Python, just with the terminal. It's right here. Timestamps. Okay, give making montages. Saving metadata. Okay, so what can we do first? So a utility I have already in some of these scripts is to make GIFs. So for example, if we go to the this one, latent, I'm actually going to do it the other way around. Text to image, text to image. Image to image, that's actually pretty generic, but yeah. Okay, here we have an example of how we save. No, this is not it. Okay, here we have an example how we save GIFs. So this is a function in which we, if we have more than one frame, we define the frame name and then we save it with image.io. Yeah, so here we are. We are passing a set of parameters. And it might make sense to add some to the name of the files, but not all of them. Okay, so let's go to our utils file. Clean prompt, ensure directory exists. All right, so this actually already trims to 220, so 255. I don't really know what the length of the names can be in a normal file on Mac or Windows. Here was I was actually manually setting it to less to 30. Um, I guess we can put an argument here called max length, and we can say like 30, and we can put that here. Right now we need to change all of our clean prompt references to clean text prompt, but I will try to do it intelligently here. So clean prompt should be clean text prompt. Clean prompt. All right, that should fix most of the appearances there. Let me go check one thing here. Okay, so clean that one. We could create one that is called make GIF or save GIF. Save GIF. Export GIF. And export montage. So yeah, we can see different ways to do this. I guess we need the frames and the save path. Let's take this function. So we get here if frames, save path, output dir. I guess we only care about this, right? Give name, save path. I mean that's kind of what this is already. So I'm not sure. Not sure if we need to. Yeah, okay. So at least we won't have to run this all the time. Import image IO. All right, so we got this. It should work this way. Yep. So here we could simply do export GIF and put our GIF name, GIF path. Right, so this one is for latent consistency. We have a lot of stuff to clean up here. So all this stuff we don't really need anymore. So I'm gonna actually clean this a lot. So I'll save. Let me make here an archive of prompts. right, so we've cleaned this up. So these were the prompts. Let's just leave this prompt here for now. And we can actually take these ones here as well. Okay, right. Okay, so again, let's remove this thing. This is kind of cool. It generates like some seeds there. Prompt. A lot of the same. Okay, so I have a set of like variables here, and I think we could have like a global config file. Let's actually ask our friend here, what's the best way to have a global configuration set of parameters in a Python repository that many scripts use? Let's see what this says. All right, so just like a global class here. Oh, one thing we didn't do either is parameters, like adding parameters to our scripts. That's also really cool. So, okay, so class config, we just do config.py. I like that. All right, let's make that config.py. And for us, we're gonna have output there. So it's for like generation. Great. Okay, so we have that, and we can use it from config, import config. And this is a way in which we can globally affect variables, so we simplify our scripts a bit. This is not being used right now. Okay, what else? Our prompts. Set this above. All right, turn that into uppercase. Gonna do the same here. Great. Okay, so this stuff that we're seeing here, we're gonna create. Hey, Mohammed Imran. Nice to seeing you all also live. Um, Thanks. Where are you connecting from? I'm here cleaning up some scripts and open sourcing everything so you guys can use it. Create an image generation pipeline which create a stable diffusion Excel pipeline with the LSSM scheduler. I need to figure out these things because it seems like these these variables here are for reduced memory. So in my machine, I don't think they're needed, but in some others, it seems like they are. So we need to also figure that out. Torch device. Yeah, here we have that again. So Mohammed is from India, almost midnight there. So generally watch the live streams during the day. Awesome. Yeah, awesome to hear. Yeah, I'm trying to see if on Thursdays I can go back to streaming a lot earlier, what I used to do before. Um, but it's been a bit complicated. So yeah, this would be like waste of iterating. I'm not gonna put this here. So let's. Okay, great. Let's see. So the other day I was trying to generate a series of numbers that were actually exponential. I'm not sure. Let's see. Let's try. Well, let's try again. Okay, here. So basically something like this. Hmm. Yeah, so for example, something like this, where the distance between the numbers at the beginning is really small, but that increases later, right? So here, always go for 11. Yeah, so we could actually plot these numbers. Mm, mm, mm. Let's try this out. Um, yeah, awesome. Yeah, thanks, Mohammed. Glad to hear. Really appreciate the comments and happy that you were able to join live. Okay, so we plot this. Oh, and this actually does show our graph. So yeah, this is really nice. So we can actually mm, try here. Let's try. I don't really care about the labels or the names. Well, for the name, we could actually put the numbers. Let me see. So if I get from here, this. Okay, so our y could be, so we could do like y is the result of this. And x is simply going to be range between 0 and y, length of y, maybe plus 1. And then we don't need this. Let's just try this for a second. All right, so yeah, that's what I meant. So it's exponential, it's growing slowly. We could, we could multiply again to make it steeper. Yeah, I guess that's what I'm looking for. So I could have here instead maybe 110 and then 1000 here to sample even more points. All right, so instead of 100, let's just try 10 as we had before. Okay. So we want to actually start at 1, right? So we will start at 1. Well, let's actually leave it at 0, and then we can add 1 later. Okay, why not make this already like this? Great. I would like to plot the numbers here, though. On each circular marker with its y value. All right, so here we're plotting these values, and it seems, right now they are too small at the beginning and too big later. It's kind of okay. I want to sample more points, so not just 10, but let's say hmm. Well, let's go back to a simple function here to remove a bit of complexity. And we can actually run it from here directly, because that way we don't have to change. Okay, so this is for one. We could multiply this. Let's see if we can multiply here. Huh. Let's multiply in the list. That's not what we want. All right, we have this graph and we would like to go up to like 50 steps, for example, right? So we would so this is always between 0 and 1. So we'll basically say x by 50 for x in, let's try that. All right, and we get this by 50. All right, and just by, okay. I think we can remap this list. Let's see. Okay, so min map will do numbers, list, and range. All right, so here I am trying to remap the values. So we will have, so remap number. Okay, so if we remap a number, we want the list is like min max in origin. So we'll put here from to range. From range. So we can extract here min val equals from range 0 max val from range 1. And then this is to range 0. Okay. Let's try this out. So we're building a remapping function. Okay, let's make y be x for ex in range. Well, let's just make y range 0 to 11. Print y, and then we remap y, and we print that. Okay, so we've remapped from this to this. Let's see if these remaps from remap number to range. And then here we can specify that we want the numbers to be between 100 and 100 and 200. To range. Oh, sorry. Here. So let's say we have here, we have 1, and then this is 0 divided by 1 minus 0, which is 1. Okay. It's not right. This should be multiplied by 100. Okay, if n is smaller than, okay, let me just not waste. All right, let's try using ChatGPT. I'm not going to waste more time on this. Okay, this makes more sense. Value original min multiplied by tax. Yeah, great. This is it. And min val max val. Well, let's try this one. We've mapped to 100, 200. Shouldn't this be 2 min? All right, that seems more like it's working. Great. So now let's say it is okay. Seems like it's working. 1000 to 1010. Great. Okay. Sounds good. All right. So we're gonna add these to our utils library. So let's put here Okay, so remap number, remap. We have to import this, import from let's see. Let's see if ChatGPT gives us a solution. Convert your script into a package. Make sure your script is part of a package and not just a standalone. This invoker is init py and then placing your scripts within this directory. Okay, let's see. We need to create touch init the py. Okay, let's see. Okay, let's not worry about this right now. Let's just move this script outside. Clear Python plot. Great. So if now we go back to what we had before, right? All right. So let's say we want 1,000 points here. Or, to be more conservative, 25 steps. We're getting the steps there. Now the only thing we need to do is remap that function to 0. So let's say we want to go from 0.25 till 7.5. That's our... All right, so we'll be doing really little increases and then go really fast. Great. Awesome. So we could also, let's say 7.5. So what if I do 7.5 minus that? Ah. So let's see, we do 7.5 minus x for x in this. Right, then we invert it. Okay, we could do the minimum. So basically the great. Okay. Sounds good. So let's say we have our number 2 range, and we want to have that range be this. So we can say our min and max. So yeah, our 2 range is max function originally. Yeah. So let's do 2 max and 2 min. So we could do, this is our range. And this would be like 2 max plus 2 min. All right, let's see. Great, and we don't do this, we'll get the inverted graph. Okay, and why are we doing all this ordeal of things? I want to do scheduling functions so we can iterate through parameters non-linearly. This one is really cool, for example, already. Let's actually... Okay, let's imagine actually we want to go from 1 step to 50 steps, right? So we'll be doing here, it's floats. That's a problem, right? But we can maybe get away with this. Let's take a look. Let's remove this. Print y. Yeah, so for steps, this doesn't make sense, for instance, because right, let's try what we had before. Let's try, for instance, this. Okay, so maybe even just with X. Great. So let's actually put this to use. Let's try this function now with these 3 lines. Well, just these 2 lines of code. In this the guidance scale example that we have here. So we could choose that our guidance scales. So if I put this here, our guidance scales are going to look like this. And I'm going to generate, let me see what my prompt is. Right, let's go for it. Let's generate here Python. Let's actually close this thing. Python, this is param guidance scale. Let's try it. Let's generate with this one. Everything's 15 steps. And this one is really, really fast. But we are changing the guidance scale exponentially. So this is at 2.25. Is this? Yeah, so this is slowly going up. And I will jump faster. What model? So this is Excel? Oh, this is normal stable diffusion. Okay, so it's not really... Let's do 25 steps. Oh, it's actually going to generate for multiple seats as well. And will this, yeah, this will create a GIF for us. All right, let's actually stop this. Let's actually only generate with 1 seed. Let's just comment this out. We want to go for 25 steps. And maybe instead of from 25, let's map to 8.5 here and start at like 1. Let's print the values here. Okay. Okay, so our list is 1, 1.03, 114, blah, 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 and then it jumps really quickly. Yeah, we might want to reduce a bit the steepness in that curve. So let's take, for example, let's take this function back and see our graph in here. This graph, we sample more values here by putting these 5 here. Otherwise, yeah, let's just try it with this generation here. Or maybe actually let's generate a few more images and let's change the seed. All right, so we've made that remapping function, and now what else are we gonna do? Grade here. Okay, I'm renaming everything I have here just to make an initial commit of everything. Um, okay, let's just actually commit everything. Okay, push. All right, so this is now officially open sourced here. So all the scripts are available. Yeah, I'll reorganize this stuff, but I think it's a good start. Okay, this continues generating, and you might not see the effect of what we did here, but the result is going to be there's like an easing function, like we're actually exponentially increasing the numbers, so the jump is going to be like it's not moving at the beginning, and then it is, and we could invert that function, so we go really fast and then slowly develop a bit more. But it makes sense to develop slower at the beginning where there are more changes sometimes, and then later we go faster when there's not that much change. So this is image. Uh-huh. Right, there we go. Why does it continue generating? That's weird. I actually have a script to change the speed of a GIF, and let's see, get writer mode. Let's take a look at. Let's see. Yeah. Let's try this. See if this actually makes it. Let's change this to 25. This path to the actual GIF path that we have. And then do scripts, GIF speed change. Try this. Okay, did something. Whoop, nice. Great. Great, you got it. Yeah, we could choose to make our GIFs boomerang all the time. The problem is that they take up double the space, so that's why I don't love it. But yeah, so that model didn't work that well, right? It wasn't that good. Okay, so we started with this thing. Let's choose the normal as Stable Diffusion Excel example. Torch device, we're also going to convert it to config. Well, we're just going to use it. So everywhere it says torch device here, we're going to convert that to the config thing here. And then from config import config. And we should be able to save a file. So one utility function that we want is dev save metadata params here in config. So we could create a params object. We could. So we could, for example, write a YAML file with a set of parameters with the info in a Python dictionary. Let's try this. And we'll have to put here a file name. Params and config. How can we... Okay, config is a class. Add a method to a Python class to return its properties as a dict. Is this already there? Maybe this is already supported. Not sure if this is gonna work. Hmm. Let's actually leave this there. We could say data equals... Let's try this. Save metadata. So from utils import save metadata, and we're gonna pass params, config, and name. So from config import config and then save metadata. Okay, did we save anything there? File YML. There you go, Nono Martínez Alonso. Great. So this works. So now we just need to extend it. We want to save the prompt. We want to save other parameters. Now I would say like concat to dictionaries in Python. Okay, so spreading. Right, let's try again. So exit, we are going to call here Python. We first import everything here, and now we call save metadata. Great. And to test that this works, we're actually gonna use it from I guess we would just pass params here. Let's try this. Params. The params. How can we pass this? Oh, very tired today. Okay, so params, we'll assume that that's a dictionary, and we want this guy, for instance, this script. I'm gonna import also from utils save metadata. What we'll do here is we'll say, okay, save metadata. We pass the params. We're gonna say here test. So let's do the test foo bar. We're gonna pass here our config, and then we will pass, even though here the config, if we're gonna be working with this repo, these utils, you can import the config itself. So from config, import config. We don't really need to pass it as an argument. Config author, awesome. So we don't need to put this here, and our file could be file3.yml. Let's say here I'm gonna put also prompt to be prompt is prompt. Great. So we're gonna execute SDL Python xdxl text to image. Why is this one still not renamed? All right, so we're gonna call this one Python text to image sdxl.py. And what we'll do is that we're gonna save the metadata for the generated image with the same. Okay, I just saw something. We're gonna save this one. We're gonna try to save the metadata before we generate. We could modify it afterwards as well, but yeah, it loaded the model, and now it's generating, and we'll save this thing. All right, so we have our prompt here. Okay, and this generated our scenic landscape and saved our file 3. Great. Okay, so what I'm gonna do now is we have a file convention here. Save metadata, it will have to construct, but yeah, we can always save the image before. So save the metadata before we generate it. So we can save the metadata, clean the prompt. and this is the image name. Image name is actually just this. I think that would be too much, but why not make it even easier? So save the image, we'll put the image name, and we can, on the utils, also say like save image name. And we'll do, oh, we need the image. Probably not worth it, right? Okay, so that's what we need to abstract, the fact that we create the output path. So this would be config, output there, and image name. So that's what we need to refactor. Image save. Right, let's generate simply for 3 steps so we don't. All right, why I was doing this is because we actually could save the image name as well here. Image name, and this file could be, so let's make this is gonna become a bit big, so let's see how we can make this easier. This file is gonna be image name, image path here .yml. Okay, let's give it a try. So we run this as this script, and let's remove these YML files that I created. And in my outputs, which have a lot of photos. Okay, we have this YML file now that has my data. So image name, nice. Great. Okay, so what else do we want to save? Definitely not foobar. So if I make a class like this one, like a class here, params, and I put here steps equals 3, for instance, right? I can print here params steps, and if I change it, what happens? All right, changes as well. So we could pass just this params class to avoid having to add a lot of stuff. Okay, so that means I can set my class to get the params, the file name. File name could actually go in the params. So YML path would be params image path dot YML. And I can pass here a to do. So this we're gonna move to a params.py file. And what I'm trying to do here is see if this approach would let us reuse variables from script to script and have some defaults. So centralized defaults. So here I would do params.prompt, params.steps, params.prompt. And again, here we don't need it anymore. We just can do params with capital P. We don't need this. Save meta. Save meta, we're gonna call this. Save meta or save data. I don't know. All right, we need this here. Great, and then here we save meta. Great, okay, so this should work. The thing is that this now is receiving this params object. Can we specify this is a params? Why not? Let's actually just do it here. Params of pi. And we're going to get that from here. So we just do that. Okay, the thing is that somebody could decide to override these things from the script itself. So we could, well, let's just try like this. All right, so we have this now. We need the image path to be always set, which is set to image right now. And what we're gonna do then through here is that we're gonna set the params image path is gonna be this thing here. And this is gonna be the params image name. params prompt scenic landscape at dusk. In that, I'm gonna set here params steps equals 10. Params image path. Right, let's try that. Okay, so I'm generating here. I have my folder of images, and we have, it's loading the model, and now we should see another of this. Great, with this data. Okay, so just the steps, because I haven't, let's cancel this. So I haven't really added the code here for this to automatically be output. And instead of me going to the other place, the one thing we could do is add this one here and return the steps equals steps. Let's try this. Okay, let's try that again. And actually, because we don't really need the model to be loaded, we can just exit here. All right, we're gonna do the same thing. So why not just do it here? All right, so we got this. I see. We can actually put it here, I think. They're just static variables. So we just return this. Let's try that. Right, so that worked here, and we have all the variables. Sounds great. Good. So we could do, or we should do the same with the config then. Yeah, so then what's the difference really between config and params? Why make it two different things? I mean, we can just make it one, right? Mm-hmm. Honestly, params or config, maybe I can just make everything one. And remove the params. Okay, let's try that one. I wish I could go now to the beginning of the live stream and record something and say like, hey, this is what we're doing today, because it's completely different than what I thought I could get time to do, but it's okay. All right, so one thing I wanted to know. So if I remove, let's say I remove my params here. I remove my params and I only have config, right? So you supposedly don't need to pass it. We just have the config dict. So we would just do here, we'll just do here config to dict, config image path. All right, so this metadata here, what is it gonna save? Save meta, okay. No model name params, okay. Move this from here. No model name params either. Okay, so this is our last file, author name, image path, blah, blah, blah. Since give at dusk. So yeah, so the thing is, the really nice thing that works easily out of the box is that here it says a scene is landscape and stuff, and the parameters that we're overriding during the session are being changed. So it seems that we need to dynamically then change some of these things. Okay, yeah, we're gonna have to ideate. I would take a second to say hi to everyone who's with us today. Say hi in the chat. We're gonna finish really soon. Just would like to know that you're there. Thanks for joining. All right, and if you're new, also one thing, don't forget to subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. Give me a thumbs up if you're enjoying the content of the channel. Okay, so let's keep going here for just a tiny bit and see what we did here. So we have a file here that is going to load the config. It's going to change the steps and the prompt. It's going to keep all the other things the same, except for this. It will override these ones. Okay, so this is what we have so far. Um, we could say, if we have an example here and we don't want to let people control from here to simplify, we could actually do something like this. We could say, okay, my steps are set here, my seed is here, and the prompt is set here. So now I could generate with this, and I don't really need to do anything. I don't really need to um, how can I say, I don't really need to expose people to any parameters, right? Like we want to change. But it's a good thing that we have here, like that we want to change parameters. And clean prompt, it seems that we could automate all this, basically, like to have the config path and the config name set automatically with one method. It would be basically something like image um, image path. Let's say get image path from the config. And again, like if this is global, I could import the config from the other place. But okay, so let's make one test to do here. One test here would be print config and print config. Okay, so I can make a method that's called print config really quickly in utils. That we're going to remove. Right, let's try that and exit from here. Class config, yeah, but all I care about is not that, is config steps and prompt. All right, so it does change. So it gets changed globally. So we don't really need, okay, we will need to do certain things with the naming when we're looping. We would be, well, not if we change the parameters actually. Okay, so we could say get image name, so image path. This could be conditional, right? But steps is always going to be there though. The problem, yeah, okay. So the problem is we will need the image path here, get image path. So this thing gets changed before this is called. And then here we just use the image path. Yeah, because otherwise it won't work. So we import this from here. And now we generate. So let's actually try. Yeah, okay. Let's try actually 30 steps. So I create this. I'm gonna Okay, my metadata gets saved there. And this contains our prompt, our output there, the image path, the image name, the seed, the torch device. We're not changing the seed here, and the author name. We could print everything really. We could also have the well, we have the torch device. Yeah, we have everything here. So yeah, and that is still working. Yeah, so this is a great way of doing it because and we can save more parameters because this is gonna help us be able to reproduce some of these things that we're using and yeah, and so for instance here. Oh, maybe we can pass the pipe. That's a nice one. So we can pass the pipe here. And pass the pipe. Okay, so we'll get here config to dict, and now we're gonna get like a pipe dict, which is gonna be and here we'll get the pipe dict. All right, so our image was generated. So it's here, and what I want to see is how we get the data from the pipeline. So pipe pipe config. Let's print the pipe config. Nice, so we get a lot of stuff from here. Pipe dict. So we're gonna put here pipe is gonna be pipe config. And data dict. Let's try this. All right, let's see if this works. No, not sure what failed right now. So yeah, in this case, we do need to wait till the pipeline generates the image to be able to save, because we are relying on the pipeline's config dictionary to yeah, to save that to the YAML. That gives us, I mean, that would make our file a lot bigger, but it gives us a great source of information, so we don't have to handle that manually to know what was used in generating an image. All right, unknown file extension for my right. Let's just put like one generation here. Print image path. Get image path. We're not returning anything, right? It's basically that. We know what this is. So config image path, and we just change this here. All right, so let's generate for one iteration only. Get the thing here, so it loads, it saves, and now, well, I don't know how it's saved before saving the image. Oh, okay, yeah, so because it saves after we load the pipeline, but before we generate. So we got here this noise. I don't really care about the types. Maybe all right. Let's see. All right. Change in strategy. I don't like this. I like the clean file with the information. So what we can do is we can open this and you say this is the pipe information, and we save two different files. Back to where we started. All right. Let's see. Well, I'm not going to care too much about this. So what we do, we simply generate again. We're now going to get two files. Two files. All right. one that has the information of the pipe. And the other one are info. Okay, and again, as I said, doing this is gonna allow us to be able to then later get content about our images and even render that content in images and presentations and things that we're gonna do. So yeah, let's keep going, preparing this stuff in a future stream. All right. I will now thanks everyone who connected with us live. If you're watching afterwards, let me know by leaving a comment on the video. I would remind you before we go that you can join the community at None of the Last Discord. Yeah, I would like to thank you a lot for watching, and I'll hope to see you next time. Bye.